Hello friends, I welcome you in lecture number 8 on Fourier series. In this lecture we will do this example. Find Fourier series of fx equal to 2x minus x square on the interval 0 to 3 and period of given function is p equal to 3. So we will first find out Fourier coefficients. Before that we find out value of L, which is equal to period divided by 2, that is 3 by 2. L is half of the period, and first we find out Fourier coefficient A0, which is given by 1 divided by L integral of function over given interval. Given interval is 0 to 3 and the value of L is 3 by 2, so we have 1 divided by 3 by 2, which is 2 by 3, and fx is 2x minus x square. So we integrate this function 2x minus x square over this interval. Now integral of x is x square by 2, so this 2 will cancel out, and integral of x square is x cube by 3, so x square by 2, but that 2 will cancel out with this, so x square minus x cube divided by 3. Limits of x are from 0 to 3. So first we put x equal to 3, so we have 3 square, that is 9, minus 3 raised to 3, which is 27 divided by 3. This is for upper limit x equal to 3. Lower limit is x equal to 0, so it becomes 0. Now this 27 by 3 is nothing but 9, so it is going to be 0. So therefore value of Fourier coefficient A0 is 0. Now we find out Fourier coefficient An. So formula for An is 1 divided by L integral from 0 to 3 fx cos n pi x divided by L dx. L is 3 by 2, so we have 1 over L is 2 by 3, integral from 0 to 3 fx is 2x minus x square, so 2x minus x square, and L is 3 by 2, so it is going to be 2n pi x divided by 3. Here we will have n pi x divided by value of L, so this is going to be 2 by 3 into n pi x, and we integrate with respect to x. So to integrate we use integration by parts with u equal to 2x minus x square and v equal to this cosine function. So this is equal to, first we write down 2x minus x square as it is, and integral of cos 2n pi x by 3 is sin 2n pi x by 3 divided by coefficient of x, which is 2n pi divided by 3. So this we can rewrite as 3 divided by 2n pi times sin 2n pi x divided by 3. So this is integral of cos 2n pi x by 3, which is sin 2n pi x by 3 divided by 2n pi by 3, which becomes 3 divided by 2n pi, minus derivative of 2x minus x square is 2 minus 2x, and integral of this sine function, which is going to be minus cos 2n pi x divided by 3 divided by 2n pi by 3, and that will multiply with 3 upon 2n pi, and we have 3 divided by 4n square pi square, and the negative sign is there, minus 9, we have to write negative sign. So, and we have 3 divided by 2n pi whole square, that is 9 divided by 4n square pi square times cos 2n pi x divided by 3. So this is the integral of this second bracket. Now we consider positive sign. We are writing alternately positive and negative. First positive sign, then negative sign, then positive sign. Derivative of 2 minus 2x is 0 minus 2 into 1, which is minus 2, into integral of this bracket. So it is going to be sin 2n pi x by 3 divided by 3 over 2n pi. So this 9 over 4n square pi square will be multiplied with 3 over 2n pi. So 3 into 9, 27, 4 into 2, 8, n cube pi cube times sin 2n pi x divided by 3, and limits of x are from 0 to 3. So now we can put the limits. First we check what we obtain for x equal to 3, and then we will see what we obtain for x equal to 0. So when x is 3, this sin 2n pi x by 3 will become sin 2n pi. If we put x equal to 3 here, 3 will cancel out and we have sin 2n pi, and n is integer, so 2n is also integer. So therefore we have integer multiple of pi, and we know that if we have integer multiple of pi, sin has value 0. So this term will be 0 for x equal to 3. Similarly, this term will also be 0 for x equal to 3. And here we will have cos 2n pi x by 3 divided by 3, that will be cos 2n pi. So there will be non-zero contribution from this term. So we simplify that term for x equal to 3. Again here we have negative into negative positive, and this term will be 2 minus 2 into 3, which is 6. We have 2 minus 2 into 3, which is 2 minus 6, which is minus 4. So value of this bracket is minus 4 when x is 3. So we have negative sign, and that minus 4 will cancel out this 4. So we have negative of 9 divided by n square pi square into cos 2n pi. Again I repeat, when x is 3, 2 minus 2x becomes minus 4. That this 4 will cancel out with this 4, and we have 3 times minus 1 multiplied, so we have minus 1, and 9 divided by n square pi square cos 2n pi. So this is the contribution for x equal to 3. So this is for upper limit. So upper limit, now we check for lower limit, that is x. So when x is 0, we have sin 0 here, so this term will vanish for x equal to 0. Similarly, this term will also vanish when x is 0, and we check what we obtain when x equal to 0 from this term. So when x is 0, here if we put x equal to 0, we will have 2 minus 2x will be equal to 2, and negative negative positive, and that 2 will cancel out with this 4. So here we will have 2. So we have 9 divided by 2 n square pi square cos 0. Cos 0 is 1. So we only have 9 divided by 2 n square pi square. 9 divided by 2n square pi square is the contribution from x equal to 0. And now this is equal to, here cos 2n pi is there, so we know that cos 2n pi is 1. So we have minus 9 divided by n square pi square minus 9 divided by 2n square pi square. This must be proper negative sign. So now we can simplify this. We can take minus 9 divided by n square pi square common, so that here we have 1 plus 1 by 2, which is going to be 3 by 2. That will cancel out this 2 by 3, and we have minus 9 divided by n square pi square as coefficients an. So n is from 1 to n, so on. So therefore Fourier coefficients an are given by an equal to minus 9 divided by n square pi square, n equal to 1, 2, 3 and so on. So these are the Fourier coefficients an. Now we find out Fourier coefficients bn. So formula for bn is 1 by L. Here integral has the limits 0 to 3 fx sin n pi x over L dx. L is 3 by 2, so we have 2 by 3. Here we have 0 to 3. Our function is 2x minus x square, and sin, if we take L equal to 3 by 2, we have 2n pi x divided by 3 integration with respect to x. So now we consider u equal to 2x minus x square, v equal to sin 2n pi x by 3, and we apply integration by parts again. So first I keep 2x minus x square as it is. Integral of sin function is minus cos 2n pi x by 3 divided by 2n pi by 3, that is in the multiplication 3 over 2n pi. Cosine of 2n pi x divided by 3 minus derivative of 2x minus x square, which is 2 minus 2x, integral of this bracket. So integral of cosine is sin 2n pi x by 3 into 3 over 2n pi. So we have square of 3 over 2n pi, which is minus 9 divided by 4n square pi square sin 2n pi x divided by 3. And in the next step we consider, or we can write this term here so that it is visible. This is positive sign, negative sign. Here derivative of 2x minus x square is 2 minus 2x, and here we have integral of second bracket is minus 9 divided by 4n square pi square sin of 2n pi x divided by 3 plus derivative of 2 minus 2x, which is minus 2. Integral of this sin function is minus cos, so we have negative negative positive, and this 9 upon 4 n square pi square will be multiplied with 3 over 2n pi. So we have 27 over 2n pi into 4n square pi square, that is 8n cube pi cube cosine of 2n pi x divided by 3, and then we find out this for x equal to 0 to 3. Now if we put x equal to 3, this term will vanish. For x equal to 3, here 3 will cancel out and we will obtain sin 2n pi, and we will have non-zero contribution from first and last term. So first we write 2 by 3, and here if we put x equal to 3, we have 2 into 3, which is 6, minus 9, which is minus 3. So this term has value minus 3. When x is 3, we have 2 into 3, which is 6, minus 9, which is minus 3. Minus 3 into minus 3 by 2n pi, that is going to be 9 divided by 2n pi into cos 2n pi, because if we put x equal to 3, we have cos 2n pi. So we have 9 divided by 2n pi into cos 2n pi. This is 9 divided by 2n pi into cos 2n pi. And here also we put x equal to 3, so we have cos 2n pi, and here we have negative sign. This 2 will cancel out with this 8, so we have minus 27 divided by 4n cube pi cube into cos 0, which is going to be 1, or we can write one more step. This is for x equal to 3. Now when x is 0, contribution from first term will be 0 because of this term. If we put x equal to 0 here, this will be 0, so that will vanish this whole term. And here also when x is 0, sin 0 is 0, so whole quantity becomes 0. So non-zero contribution is only from last term, and we have to consider minus from lower limit. And here if we take x equal to 0, cos 0 is 1, and here we have negative of 27 divided by 2 will cancel out, 4n cube pi cube. And here I made a mistake. Here I was putting x equal to 3, so this is going to be cos 2n pi. This was for x equal to 3, and this is for x equal to 0. So now we can simplify again. We know that cos 2n pi is 1, and here we have 9 divided by 2n pi, because cos 2n pi is 1, we have minus 27 divided by 4n cube pi cube. This is negative positive, so we have 27 divided by 4n cube pi cube. So this is going to be 0, and here 2 will cancel out, and this 3 will cancel out, so we have 3 divided by n pi, which is value of each Fourier coefficient Bn. So therefore the Fourier coefficients Bn are given by Bn equal to 3 divided by n pi, n equal to 1, 2, 3 and so on. So we have obtained all the 3 Fourier coefficients, so we are able to write down the Fourier series. So first we write down the formula for Fourier series of function of any period. Fourier series of fx is, here our function is continuous at every point, so we can write equality sign here. Fx is a0 by 2 plus sigma n equal to 1 to infinity a n cos n pi x divided by L plus sigma n equal to 1 to infinity b n sin n pi x divided by L. Now our function is 2x minus x square, and let me check what was the value of a0 which we obtained. a0 is 0 and an is minus 9 over n square pi square. So an is minus 9 over n square pi square. a0 is 0. So we have sigma n equal to 1 to infinity. An is minus 9 over n square pi square. L is 3 by 2. So we have n pi x divided by 3 pi by 2, which is cos 2 n pi x divided by 3, plus sigma n equal to 1 to infinity. Bn which we have obtained is 3 over n pi. Here also if we put value of L, we have sin 2 n pi x divided by 3, and this is valid in the interval 0 to 3. So we can rearrange this Fourier series by considering the terms which are independent of n outside the summation. In this term, minus 9 by pi square is independent of n, so we take it outside, and here we have sigma n equal to 1 to infinity 1 by n square cosine of 2 n pi x divided by 3. Here we have 3 over pi is independent of n, so we take it outside. Sigma n equal to 1 to infinity 1 by n sin 2 n pi x divided by 3. X is in between 0 and 3. So this is the required Fourier series of function 2x minus x square in the interval 0 to 3. So I think now you are able to find out Fourier coefficients for functions of any period L, any period 2L. So this is all about this lecture. I stop here. Thanks for watching.